So the second problem over here is integration of dx upon 3 minus 5x. So this can also be written as 1 upon 3 minus 5x dx. Okay, as I said earlier, that this particular problem can be solved using many ways, but then this is the most easier of the way. So I'll compare this with 1 upon x formula. It's of the same format 1 upon x. So if I compare this with x up 1 upon x formula, x is nothing but 3 minus 5x, and 3 minus 5x is LAT, linear algebraic term. So we can compare this with 1 upon x formula. So 1 upon x integration is log mod x. So the integration of 1 upon 3 minus 5x will be log modulus 3 minus 5x upon dy dx of 3 minus 5x plus c. So that is equal to log mod 3 minus 5x upon minus 5 plus c. Equation, question number 2. Okay. The third question. Question number 3. So the next problem over here is integration of root of 1 plus x dx. So 1 plus x is linear algebraic term. So I'll take that root as half. So this is nothing but x raised to n, x raised to n plus 1 upon n plus 1. And down chain rule, dy dx of 1 plus x. Now 1 plus x is linear algebraic term. Hence we were able to apply this particular formula. So this is equal to 1 plus x raised to 3 by 2 upon 3 by 2 plus c 2 by 3 1 plus x raised to 3 by 2 plus c. Okay. Next question, question number 4. Integration of cosec square x 1 plus cot x. Okay. Now again, our observation should be very clear over here. The derivative of cot x is cosec square x minus cosec square x. So forget about that minus n, but then we are having cosec square x. So this problem also can be solved using two different ways. Method number 1, I'll multiply minus inside and outside because the derivative of cot x is minus cosec square x. Now the purpose of this was the derivative of the entire denominator. You can also tag in 1 along with cot x because the derivative of 1 is 0. The derivative of 1 plus cot x is minus cosec square x. Okay. So derivative of the denominator is present in the numerator. So you can use this particular property log mod f of x. The minus sign will remain outside, one of the minus signs. And then in the last step, you can just put f of x as 1 plus cot x. Okay. So this is one way to solve this particular problem. The other way, cosec square x 1 plus cot x. Now the derivative of cot x is cosec square x. So you can put cot x as t, but I would rather prefer put 1 plus cot x is equal to t. Okay. So dy dx of 1 plus cot x, dy dx of t minus cosec square x dt by dx. So cosec square x dx is minus dt. Okay. Now look at this equation number 1 and look at this encircled part. I can observe we can make a group of cosec square x dx. So I'm grouping cosec square dx. So this minus sign goes on the right hand side, it becomes minus dt. So from 1, the next step, okay, from equation number 1, okay, integration. The encircled part is minus dt and down it is t. So minus sign outside 1 upon t dt. Okay, so it can be expressed as dt upon t can be expressed as 1 upon t into dt. So minus log modulus t. Now it is t. T is nothing but 1 plus cot x. Okay, that was your question number 4. Let's go to question number 1. Integration of 6x minus 8 dx 3x square minus 8x plus 5. Now in our earlier recording, I had solved question number 5 first and explained both the methods. Okay, by mistake. So one I am starting it over here. So again, there are two methods to solve this. Just by trial and error basis, find out the derivative of the denominator. The derivative of the denominator is 6x minus 8. So if you derivate the denominator, you get 6x minus 8, which is luckily present in the numerator. So this is function of x. Numerator is derivative of the function of x. So f dash x upon f of x is log mod f of x. So log mod 3x square minus 8x plus 5 plus c. Okay. This was question number 1. Now, if you want to solve this problem using method of substitution, you can put this part as t and practice it on your own. Okay. Question number 6. Integration of sec x into log sec x plus tan x dx. Now, this problem is not that easy to interpret at one go. There is no denominator as well. I'll just take this log term as t, put log sec x plus tan x is equal to t, equation number 1. Derivate this log sec x plus tan x dy dx of t 1 upon sec x plus tan x into dy dx of sec x plus tan x. Chain rule. Derivative of log x is 1 upon x, so derivative of sec x plus tan x is 1 upon sec x plus tan x into dy dx of sec x plus tan x. dt by dx. So the derivative of sec x is sec x tan x and derivative of tan x is sec square x. So sec x into tan x plus sec square x upon sec x plus tan x is equal to dt by dx. Okay. Yeah. So take sec x common in the numerator. So tan x plus sec x upon sec x plus tan x dt by dx. Cancel this out. Now look at equation number 1. Look at equation number 1. So sec x dx, this group we can make. So sec x into dx is nothing but dt. Okay. So this is equal to dt. So from 1, integration of sec x into dx is nothing but dt. And log sec x plus tan x is t. So this is t raised to 1 dt. t raised to 1 plus 1 upon 1 plus 1 by 2. Okay. And t is log sec x plus tan x. Just put the whole square over here. Now that 2 square, wherever the square is mentioned over here, that particular 2, this we cannot take it over here because it's the power of log. It's not the power of sec x plus tan x. Okay. So don't make that mistake. So that was the end of question number 6. So the next problem, that is question number 7. Integration of cos root x upon root x. Now the derivative of the new denominator is not the numerator. Derivative of the denominator root x is 1 upon 2 root x. But then in the numerator there is trigonometric function. So we really cannot apply the property over here. And as I said you earlier, method of substitution can get handy at times. So this is equation number 1. Okay. So I'll just write this as dx, which is equal to cos root x into 1 upon root x. Because a upon b can be written as a into 1 by b. Purpose you will understand. Now the derivative of root x is 1 upon 2 root x. So that 1 upon root x is present in the problem. 2 is just a constant. Okay, so I'll put root x as t and I'll mark this as the equation number 1. Put root x is equal to t d by dx of root x d by dx of t 1 upon 2 root x dt by dx. Now look at equation number 1 and look at the derivative part, this part. We can create a group of 1 upon root x dx. So 1 upon root x dx, 1 upon root x dx is equal to 2 dt. 2 is not required over there. So 1 upon root x dx is dt. So from 1 integration cos t, because root x is t, 1 upon root x dx is 2 dt. So 2 outside, integration of cos t dt, 2 sin t plus c, and in the last step, you're going to put t as root x. Okay, that is how you're going to solve this particular problem. Next question. Question number 8. Integration of x e raised to x square dx. Now the derivative of x square is present in the problem. Derivative of x square is 2x. 2 is a constant, so it's not really problem creating for us, but then that x is present in the problem. Okay. So I'll put root x square equal to t. Take that term as t whose derivative is present in the problem. So dy dx of x square, dy dx of t, 2x dt by dx. Now look at equation number 1 and look at what we have derivated over here. Okay. So in equation number 1, we can observe x dx. So x dx is nothing but dt by 2, or rather it will be dt by 2. X dx is equal to dt by 2. So from 1 integration x dx is dt by 2 e raised to t into dt by 2, because x square is t. Now you can take half outside. It's a constant, e raised to t dt, and e raised to t is x square. That should be your final step. Okay, let's go to the next problem. That is question number 9. Okay, e raised to m tan inverse x 1 plus x square. Okay, now derivative of tan inverse x is present in the problem, 1 upon 1 plus x square. So I'll just express this in other format. See, I'll write this as e raised to m tan inverse x 1 upon 1 plus x square dx. Equation number 1. Put tan inverse x is equal to t dy dx of tan inverse x dy dx of t 1 upon 1 plus x square is equal to dt by dx. So 1 upon 1 plus x square dx is equal to dt. So I decided to take 1 upon 1 plus x square and dx terms together. Okay, because it's there in equation number 1. Okay, so from 1 integration of e raised to mt, because tan inverse x is t, and this circles is nothing but dt. See, 1 upon 1 plus x square dx is equal to dt. So e raised to mt is e raised to mt upon dy dt of mt. M is a constant. Okay, so e raised to mt upon m. Derivative of mt is m, because d by dt of t is 1, m outside. Now in the last step, replace this t with tan inverse x. This was question number 9. Let's go to question number 10. Integration of sec square log x the whole upon x. Okay, sec square log x the whole upon x dx, which is equal to sec square log x into 1 upon x, because the derivative of log x is 1 upon x and it is present in the problem. Okay, let this be equation number 1. Put log x is equal to t dy dx of log x dy dx of t 1 upon x dt by dx. Now look at equation number 1. 1 upon x dx. So 1 upon x dx is nothing but dt. Okay. So from equation number 1, this is going to be sec square t and this is dt. Integration of sec square t is tan t, and then t has to be replaced with log x. That will be your final answer. Okay. Let's go to question number 11. Integration of sin square x cos x dx. Now the derivative of sine is cos, which is present in the problem. Okay. So put sin x is equal to t d by dx of sin x d by dx of t cos x equal to dt by dx cos x dx is equal to dt from 1. So sin x is t, so this will be t square. Cos x dx is dt. So t raised to 3 by 3 because x raised to n formula, and then replace this t with what? Sin x. So this will be sin x the whole cube upon 3 plus c. Okay. Question number 12. Integration of sin inverse x the whole cube upon root 1 minus x square dx. Root 1 minus x square dx. So the derivative of sin inverse x is present in the problem. 1 upon root 1 minus x square. So just separate it, or rather express in this particular format in which I have written. Put sine inverse x equal to t dy dx of sine inverse x dy dx of t 1 upon root 1 minus x square is equal to dt by dx. Now look at equation number 1. 1 upon root 1 minus x square dx is nothing but dt. So group those terms 1 upon root x square 1 minus x square dx dt. Okay. So from 1 integration sine inverse x is t, so t cube, and this red colored part will be dt t raised to 4 by 4 plus c. Now replace t with sine inverse x. Resubstitute t as sine inverse x towards the end of the problem. Let's go to question number 13. Integration of sec raised to 4x tan x. A bit tricky this is. So this can be written as sec square x into sec square x into tan x. So sec square x is 1 plus tan square x. This tan x I will write it over here. And this x square x I'm not going to change it. I'll keep it as it is. Okay. Now don't you observe derivative of tan is present in the problem, that is x square, right? So let this be equation number 1. Put tan x is equal to t. Derivative dy dx of tan x dy dx of t. T is not a constant, guys. So sec square x is equal to dt by dx. Now look at equation number 1. Sec square x dx. So sec square x dx is going to be dt. So from 1 integration of 1 plus t square into t dt. Okay. So this is t into 1, that is t into t square, which is t cube. Individual integration t raised to 1, that is t raised to 2 by 2 plus t raised to 4 by 4. And then put the value of t as tan x. Resubstitute the value of t as tan x. Okay. That was your question number 13. Let's go to question number 14. Question number 14. Integration of x cube upon x square plus 1 the whole cube. Okay. Now the derivative of x square is x. Okay. So that x we can get in this particular manner. X cube can be written as x into x and x square plus 1 the whole cube. Okay. Now the derivative of x square is 2x. 2 is a constant, but then x is present in the problem. Okay. X is present in the problem. Right. So put x square as t. Put x square as t. But then I take x square plus 1 as t. Because one derivative is as it is 0. So dy dx of x square plus 1 is equal to dy dx of t. X square is 2x dt by dx. Now look at equation number 1. X dx is equal to dt by 2. X dx is dt by 2. So from 1 integration x dx is dt by 2. X square plus 1 is t So this is t cube. Now we are left with only this x square, this particular x square, the yellow colored. So that x square is nothing but t minus 1. That x square will be written as t minus 1. So half outside, t upon t cube minus 1 upon t cube dt, half 1 upon t square minus 1 upon t cube dt, half t raised to minus 2 t raised to minus 3 dt. Okay, I'll go back to the previous slide. Here I'm splitting and I'm taking half outside because there is 2 over here. Okay, x raised to n, x raised to n. So half x raised to n plus 1 upon n plus 1 minus 2 plus 1 upon minus 2 plus 1 minus 3 plus 1 upon minus 3 plus 1. So half, this minus goes up and t raised to minus 1 comes down, 1 upon t. Now this minus into this minus is plus and 1 upon t square. Now after this, you are going to resubstitute the value of t. Please resubstitute the value of t. Okay. So let's go to question number 15. Question number 15. Integration of 1 plus tan x plus log sec x. So this can be solved using two ways. If you derivate the denominator, I'm just taking a chance, I'm not knowing for sure. If you derivate the denominator, you will get the derivative of the denominator as 1 plus tan x only. Because x is 1, log sec x is 1 upon sec x into d by dx of sec x, which is sec x tan x. So derivative of the denominator is numerator only. Okay. So you can use f dash x upon f of x property. F dash x upon f of x is log f of x. Now method, and you can put the value of f of x. F of x is x plus log x. Method number 2 is you can put x plus log x st because its derivative is present in the problem. Okay. Right. So let's go to question number 16. Integration of sec raised to 4x dx. So this can be written as sec square x into sec square x dx. So this is equal to 1 plus tan square x into sec square x dx. So I've used fundamental at one of the sec square. Now I'll put tan x as t because tan ka derivative is present in the problem, that is sec square x. So put tan x is equal to t dy dx of tan x dy dx of t sec square x dt by dx. So sec square x dx, we'll club this too because we are having sec square x dx. Sec square x dx is dt. Okay. From one integration, I'll take you to equation number 1. Tan x is t. So this is 1 plus t square and sec square x dx is sec square x dx is dt. So t plus t cube upon 3. T plus t cube upon 3. Okay. That was your question number 16. Question number 17. Integration of sin log x upon x dx. Integration of Sin log x into 1 upon x dx. Okay, equation number 1. Put log x is equal to t. Okay, I've given you the hint. You can please solve this further. Okay, because it's very simple. If you are getting stuck anywhere, you can ask me later on. Right? So let's go to question number 18. Integration of cos x minus sin x upon 1 plus sin 2x. So this is cos x minus sin x upon cos x plus sin x the whole square. Okay. Now this is a very interesting case, I should say. If there is no square in the denominator, then this will be f dash x upon f of x. Derivative of cos is minus sin is cos. But then the square creates a lot of problem over here. Okay. So we'll take this term within the bracket as t. Put cos x plus sin x as t because its derivative is present in the problem. If it is not square, then we can use f dash x upon f of x property as well. Okay. So put cos x plus sin x as t dy dx of cos x plus sin x dy dx of t minus sin x plus cos x is equal to dt by dx. Now look at equation number 1, cos x minus sin x dx. So this group I am going to make. So cos x minus sin x, okay, into dx is equal to dt. Now from 1 integration, okay, cos x minus sin x dx is dt upon t square. Why t square is because this part is t. It is t square. Okay. So 1 upon, or rather t raised to minus 2 dt. Then you use x raised to n formula. Okay. X raised to n formula. X raised to n plus 1 upon n plus 1. And then replace the value of t with cos x plus sin x. Right? We'll go ahead with question number 19. Integration of 1 plus sin x upon 1 plus cos x. Sin x half angle 1 plus 2 sin x by 2 cos x by 2 and 1 plus cos x is 2 cos square x by 2. Okay. So here and here I have applied half angle. Now we are going to split because there is a plus sign in between. So 1 upon 2 cos square x by 2 plus 2 sin x by 2 cos x by 2 upon 2 cos square x by 2. Okay. Now here 2 cos is gone. So send cos square up. So this is sec square x by 2 plus tan x by 2. Okay. Individual integration half because this 2 is down. Integration of sec square x by 2 is tan x by 2 upon dy dx of x by 2 plus tan x by 2 integration is log mod sec x by 2 upon dy dx of x by 2. Dy dx of x by 2 is half, so that you can simplify further. But then this is what the main problem is. Okay. Question number 20. Okay. Sin theta plus cos theta upon root of sin 2 theta. Okay. So integration of sin theta plus cos theta. Now try and understand this. This you have to remember 1 minus 1 minus sin 2 theta. Okay. See, the logic over here is if you expand this 1 and 1 will go minus minus will be plus and we are left with sin 2 theta. So this step you remember. Fine. Now take 1 minus sin 2 theta is key. 1 minus sin 2 theta is t. Okay. Or rather we'll do one more thing. Sorry. 1 minus formula will apply before method of sum. So sin theta plus cos upon root of 1 minus cos theta plus sin theta the whole square. Okay, whole square d theta. Before sin 2 theta, you write 1 minus, then bracket 1 minus sin 2 theta. Now you can do this, take cos theta plus sin theta as t. I think this should be minus, very sorry. Okay, cos theta minus sin theta is t because there is minus over here. Okay, since there is minus over here, so this has to be minus. So cos theta minus sin theta is t we will take. So that I'll do on the next page. Put cos theta minus sin theta is t. Now instead of dy dx, we'll do dy d theta. Okay, dy d theta of t. So minus sin theta minus cos theta d t by d theta. Take minus sign common, and in the numerator I'll just write sin theta plus cos theta dt by d theta. Now we'll observe equation number 1. This is equation number 1. Sin theta plus cos theta d theta. So here also sin theta plus cos theta d theta is equal to minus dt. Sin theta plus cos theta d theta. Minus sign on the right hand side, minus dt. Okay, so from 1, integration of minus dt root of 1 minus t square. Okay, because this is t, so 1 minus t square, right? So minus 1 upon root of 1 minus t square dt. Now this is sin inverse t formula, direct formula which I have given you. And then last step you have to put the value of t, which is equal to cos theta minus sin theta. Okay. Some teachers expand this particular answer further simplified, but then it is not really required. Okay, so we'll keep our solution up to here, right? Just a second. No, they have just kept it till here, but then they have got sin theta minus cos theta, and then minus is not there. It works out to be the same thing, so don't worry about it. Okay, because sin inverse of minus x is minus sin inverse x. So never mind about this. So we can just stop our solution over here. Let's go to question number 21. Okay. Cos x dx cos x by 2 sin x by 2 the whole cube. Okay. Now down there is cos and sin. So here in the at the top we'll just use half angle formula for cos 2x. So we'll involve the formula which has both sin and cos square x by 2 minus sin square x by 2. So cos x by 2 plus sin x by 2 the whole cube. In the numerator I have applied half angle formula, x becomes x by 2. There are 4 formulae for cos, but then I have taken cos square minus sin square. Okay. Now in the numerator, I'm going to do a plus b, a minus b. So a minus b into a plus b. Okay. Right. So one term will get cancelled over here. So I is equal to cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2, the whole square. Equation number 1. Now same case we had done earlier, but then the angle was x, not x by 2. So what I would recommend is take this particular term as t. Don't take the square along with it. Only the bracket term as t. So put cos x by 2 plus sin x by 2 is equal to t dy dx of cos x by 2 plus sin x by 2 dy dx of t. Okay. So minus sin x by 2 into half. Why half? Because dy dx of x by 2 also we need to take chain rule plus cos x by 2 into half is equal to dt by dx is equal to dt by dx. So half cos x by 2 minus sin x by 2 equal to dt by dx. So I have taken half outside common. Now look at equation number 1. Cos x by 2 minus sin x by 2 dx. So cos x by 2 minus sin x by 2 dx equal to this 2 will go over here 2 dt. Okay. So equal to 2 dt. So from 1 this thing is 2 dt, the tick marks is 2 dt, and this is t square. Take 2 outside, t raised to minus 2 x raised to n formula, and then replace t with cos x by 2 plus sin x by 2. Okay. So this part I'm giving you for self study. Let's go to question number 23. Integration of tan x upon sec x plus tan x dx. Convert everything into sin and cos. Sin x upon cos x, 1 upon cos x, sin x upon cos x. So down you can take LCM. So cos terms will get cancelled, and this will be sin x upon 1 plus sin x dx. Sin x upon 1 plus sin x dx. Now this is a case of Indef 1. Whenever there is 1 plus sign in the denominator, multiply and divide with the conjugate of the denominator. Okay. Multiply and divide with 1 minus sin x. Now this problem you can try on your own. Okay. Let's take question number 26. Integration of x root x upon root x plus 5. Now the degree of the numerator and denominator is same. Forget about that root, but then x raised to 1, x raised to 1 both places. So we'll make numerator same as denominator. So plus 5 minus 5. So we made numerator same as denominator, but then to adjust plus 5 we have to subtract minus 5. So x plus 5, now split root of x plus 5 minus 5 upon root x plus 5 dx. Now a upon root a is root a. We know this, a upon root a is root a. Okay, so x plus 5 upon root x plus 5 is root x plus 5. minus 5 upon root x plus 1. Okay, so this is x plus 5 raised to half minus 5 into x plus 5 raised to minus half. Because root will go up, so half will go up and it will be minus half over here. Now this is x raised to n individual integration. So x raised to 5 upon 3 by 2 and 3 by 2 d by dx of x plus 5 is 1 because x plus 5 is LAT. So derivative of x plus 5 will be down, but then that any which ways it is 1. 5 x plus 5 raised to half upon half, and this is 1. So you can take this 2 up and finish the problem. Okay, so that was your question number 26. So let us go to question number 27. Integration of x plus 1 x plus log x the whole square upon x dx. So this can be written as x plus log x the whole square into x plus 1 upon x. Now here you can split x plus log x the whole square x upon x, which is 1 plus 1 upon x. Okay, equation number 1. Now I'll just give you the hint. Derivative of x plus log x is present in the problem. Derivative of x is 1 and log x is 1 upon x. So derivative of x plus log x is present in the problem. So take this particular term as t and further you can solve. Okay, right? And yes, so you can solve this further. Question number 28, integration of x square e raised to x cube cos e raised to x cube dx. So I'll put e raised to x cube as t, derivative of e raised to x cube, derivative of t, e raised to x cube is e raised to x cube, dy dx of x cube, dt by dx. Okay, e raised to x cube into 3x square dt by dx. This we took chain rule, dt by dx of x cube. And this part is derivative part. So this dy dx will come in the numerator, not the denominator. Now look at equation number 1. X square e raised to x cube dx. So x square e raised to x cube dx will be dt upon 3. 3 is not required over here. So x square e raised to x cube dx is equal to dt by 3. So from 1 integration this particular part into dx is dt by 3. Okay, and yes, cos t, this will be cos t. So 1 upon 3 outside, integration of cos t dt, 1 upon 3 outside, sin t, put the value of t as e raised to x cube. Okay, one last problem, that is question number 38. Integration of x upon e raised to x square. Now derivative of x square is present in the problem, that is 2x x. 2x, that is x. 2 is a constant. So put x square equal to t, d by dx of x square dy dx of t, 2x which is equal to dt by dx. So x dx, okay, x and dx. So x and dx, okay, is dt by 2. So from one integration x dx is dt by 2, 1 upon e raised to t. So half outside, e raised to t dt, sorry, e raised to minus t, now this will be, let me just check, e raised to t goes up, so it will be e raised to minus t. So e raised to minus t is e raised to minus t upon d by dt, don't take d by dx, of minus t. So half e raised to minus t, t is x square, and dy dt of minus t is minus 1. Okay, so minus half, this minus will go up, and e raised to minus x square, e raised to x square, 1 upon e raised to x square. This should be your final answer. Fine. Okay, thank you.